The big shift this week is that AI is starting to learn motion and 3D structure without depending on the old crutches, latent bottlenecks, pose skeletons, or full 3D labels. Instead, models are being trained closer to raw visual reality, and that unlocks sharper scene geometry, more faithful character interaction, and surprisingly strong human motion priors from weaker supervision. What ties these papers together is a push toward end-to-end training that preserves context instead of throwing it away. And once you see how that works, the trade-offs, failure modes, and scaling recipe become a lot more interesting. Let's explore the first paper, PixWorld Unifying 3D Scene Generation and Reconstruction in Pixel Space. PixWorld, from AI Sphere and Nanyang Technological University, unifies 3D scene reconstruction and generation by moving diffusion from latent space into pixel space and supervising a pixel-aligned 3D Gaussian splatting representation directly through differentiable rendering. Unlike prior latent space systems such as Gen 3R, it removes the VAE/RAE bottleneck and adds a geometry perception loss built on a frozen 3D foundation model, Pi3, so the model matches rendered views not only photometrically, but also in geometry-aware feature space. The method uses a 24-layer DIT with 1 and 44B parameters, trains from scratch on about 67K multi-view scenes from real estate 10K and DL3, DV 10K plus 10M, blip 30 images, and evaluates on real estate 10K, DL3, DV 10K, and World Score. It achieves the best reported single image generation scores on real estate 10K, reaching 18.88 PSNR and 0.614 AUC. At 5, improves PSNR to 16.5 and AUC at 5 to 0.485 on DL3 DV 10K, and wins the world score average at 71.04. For reconstruction, it attains 26.21 PSNR on real estate, 10K and 23.18 on DL3 DV, 10K with 4 view inputs, while an ablation shows that removing geometry perception drops real estate 10K 1 view PSNR from 19.12 to 17.99 and AUC at 5 from 0.642 to 0.562, confirming that the new structural loss is central to long horizon geometric fidelity. Let's explore the second paper, Scale 2 Unifying Controlled Character Animation with End-to-End in Context Conditioning. Scale 2 from Tsinghua University and Z.AI reframes controlled character animation as a fully end-to-end in-context conditioning problem, bypassing brittle pose skeletons and masked background intermediates that lose occlusion, interaction, and environment information. The paper unifies character image animation, character replacement, and multi-character interaction through a single DT-based WAN2, 1, 1, 4B, I, 2V, backbone, using direct video token concatenation, in-context mask conditioning, and mode-specific shifted row P to separate animation and replacement behavior without changing the visual context. To solve the pair data bottleneck, it builds motion pair 60K, a heterogeneous synthetic corpus of 59,376 end-to-end motion transfer pairs with a 3-to-1 mix of animation and replacement data, generated through an agentic pipeline that uses Scale, WAN Animate, Mocha, SAM3, Gemini, and Google DeepMind's Nano Banana. The model is trained for 3,500 steps, then refined with 400 steps of bias-aware DPO, where preference pairs are constructed from fine-grained hand errors and optimized with a hand region mask. This post-training uses LoRa rank 128 and a DPO temperature of 5,000. Across Studio Bench and Xdance benchmark, Scale 2 reports stronger cross-identity motion following, identity isolation, and environment integration than Scale, WAN Animate, Mocha, and even proprietary Kling 3 in human preference tests, while the ablation on multi-character video benchmark scores shows the full model reaching 4.63 imaging quality and 4.23 temporal consistency. The central contribution is not a new motion representation, but a scalable recipe for learning controlled animation directly from raw video context and synthetic preference correction. Let's explore the third paper, Video MDM towards 3D human motion generation from 2D supervision. Video MDM, developed by Amir Mann, Gal Michael Harari, Marav Kedar, and Or Litany from Technion and NVIDIA, reframes 3D human motion generation as a cross-modality diffusion problem trained only on 2D pose supervision from monocular video. A pre-trained 2D to 3D lifter supplies noisy 3D teacher trajectories, but the model learns natively in 3D and is supervised through depth-aware 2D reprojection, a loss the authors show is equivalent in expectation to direct 3D MSE under mild camera assumptions. The method also adapts 3D motion regularizers to 2D, including a depth-weighted velocity loss and a ray projection-based representation alignment term for rotations, joint velocities, and foot contacts. On a 2D only human ML 3D setup with 14,616 motion sequences, video MDM reaches FID 0.88, nearly closing the gap to fully 3D. Supervised MDM at 0.54 and beating the strongest 2D baseline. On Fit3D, it cuts MPJPE from 228.47 mm for WOM to 111.24 mm and reduces acceleration error from 17.66 to 3.16 meters per square second. On MBA, human raters preferred video MDM over MAS in 64% of pairwise comparisons, showing that 2D supervision alone can produce a coherent 3D motion prior that generalizes beyond the lifter that bootstrapped it. That's a wrap on today's AI paper highlights. Thanks for watching.